All right, so here I'm going to talk about solutions and dilutions. Now, this can be kind of a tough concept for some Bio 150 students, so if you're still struggling after this, make sure that you seek out help. Now, you should remember that solutions are specific solutes dissolved in a solvent, and we're really talking about aqueous solutions, so these would be different solutes like sodium chloride or glucose or urea dissolved in water. Now, in a lab, you store your solutions in a stock solution. And this is just going to be the highest concentration solution of your specific solute. Now, the actual concentration can vary, and the unit of the concentration can vary as well. In the lab, we worked with 1 molar stock solutions, but you could have a 5 molar or a 20 molar. You could even have a 20% stock solution. It just depends on how it was made. So let's pretend we're using the stock solution that we had in the lab, and let's say that we're interested in making dilutions of sodium chloride using this 1 molar stock solution. So the way that stock solution was made by the lab staff is they would have poured a certain mass of crystallized sodium chloride and then filled up that container with water so that you had this homogeneous, this really even mixture of 1 molar sodium chloride. Now, depending on what experiment you're doing, you might need many different dilutions or just one. Now, in the osmosis lab, you all made 6 different dilutions that ranged from 0 to 1 molar of the solute. For simplicity, let's just pretend that we're making 3 dilutions. Let's say we're doing, 0.0 molar, 0.25 molar, and 0.5 molar. So these are lower concentrations than the stock solution. So we're going to have to dilute the stock solution with water in order to get to the right concentration. So how do we do this? Now let's go to our equation that we're going to use to calculate these volumes. So the equation is C1V1 equals C2V2. Now if we go ahead and define what our variables are, then we can solve for our unknown. So let's say that this side of the equation is representing what's going on with the stock solution. And this side of the equation is what's going on with a specific dilution. So we're going to end up with doing this 3 different times for our 3 different dilutions. Okay, so the stock concentration is 1 molar. And that could vary depending on, how the stock solution was made. The volume of our stock is unknown. We don't know how much of this stock solution we need to put into each beaker in order to get the correct volume, or correct concentration. That's what we're solving for. Now, the concentration of the dilution is going to vary. So it's going to be either 0 molar, 0.25 molar, or 0.5 molar, depending on which dilution we're talking about. Then finally, we need our final volume of our dilution. And let's say we're making 200 milliliters of this dilution. I think that's what we made in the lab. But that can vary. It just depends on what you need for your specific experiment. Okay, so again, now we have our unknown is V1, and we want to solve this equation for V1. So I'm going to come over here and just do that again. And, if you need a little help with algebra, there's no shame in that. So if we want to get our V1 isolated, we can algebra legally, divide each side by C1 in order to isolate that unknown. So the equation we're going to work with is C2V2 over C1. Okay, so I'm going to get rid of this. We need a little more space. We're going to get rid of this. And let's kind of scooch this up a little bit so that we've got space to work. All right, so let's say for our first equation, we're going to make our 0 molar dilution. So we know that our C2 is going to be 0 molar, and you always have to include the units when you're writing out equations to make sure that you're doing it correctly. V2 is 200 milliliters, and it's all over 1 molar. So we can cancel out the molar, so our final unit is going to be in milliliters, which is correct, and it is 0 milliliters. So what that means is that there will be 0 milliliters of the stock solution put into this beaker. Now, that seems obvious, right? If it's a 0 molar dilution, it should have none of the solute in it. Now we have to figure out how much water to add to get our dilution up to the right volume. So just plain water is going to be the final volume minus the volume of the stock solution that you added. So in this case, it would be the water that you would add would be 200 milliliters minus 0 milliliters for 200 milliliters of water. So if you added first 0 milliliters of your stock solution, then you would come along and pour in you would measure out 200 milliliters of water. Your final 200 milliliter dilution is at 0 molar. All right, let's do the next one. So again, our final concentration for this next one is 0.25 molar times 200 milliliters all over 1 molar. So we would end up with 50 milliliters of the stock needing to be added. So we would then take our pipette or graduate cylinder, and we would measure out 50 milliliters of the stock solution and add it. So now you would have a little bit of stock solution in there. Now, how much water do we add? Again, the water is going to be the final volume minus the volume of your stock solution for 150 milliliters of water. So then you'd come along and you'd add your 150 milliliters of water all the way up so that you have the same final volume. Okay, and we're kind of running out of room here, but we can do the last one where we want to make a 0.5 molar dilution that has a volume of 200 milliliters all over the stock concentration, and we would end up with 100 milliliters. So you'd use your graduate cylinder and you would measure out 100 milliliters of the stock solution, and you would pour that in to your last beaker, and then you've got to figure out how much water. So again, the water is going to be 200 milliliters minus 100 milliliters of the stock solution that you added. So you need to fill it up, with 100 milliliters of water to get to that final volume. All right, and then, again, if you were to look, here's an eyeball looking this way, you would see that all of your dilutions would be the same volume, which is sort of the goal at the end of the day here. But they have different concentrations of the solute. All right, I hope this helps. If you need more clarification or want to do more practice problems, please let me know.